winning flight where it won the $10 million. And so when Richard saw this vehicle, Spaceship One, he said, this is something, and that's Bert Rutan, the designer of Spaceship One, brilliant guy. But when Spaceship One went up in 2004, he said, this is something that I can turn into a business. I can make this into something that we can sell tickets with. It could be a real business. And with that idea, we signed an agreement with Scaled Composites to design the first commercial reusable spaceship. And since then, we've been working on these vehicles. And it's an incredibly exciting moment because we're so close now to the finish line, or rather the starting line of commercial human spaceflight. Let me tell you a little bit about these vehicles. So what you can see here is to the sides. So I was talking a little bit about the mission profile, and I'll tell you a little bit more about it now. So if you, since so many of you want to go to space, if you were flying with us, this is what would happen. On the morning of your space flight, you would board the spaceship, and the spaceship would already be attached to the carrier aircraft. And the carrier aircraft would take off, and it would circle up to about 52,000 feet up, which is also pretty high, as it is. And then when you got to 52,000 feet, you would be released. We prefer not to use the word dropped. We just, we released the vehicle, and immediately the rocket engine would fire, and you execute a gamma turn, and you start going straight up, and you get going faster and faster, and you feel G-force of up to 4 Gs on your body going up. And you're going Mach 3.5, which for those of you who know, I mean, that's pretty fast, straight up. And the rocket engine will stop after about 65 seconds. So not very long. You burned your rocket for about a minute, and at that moment, you'll still be rocketing up very fast because you have a lot of momentum. But at that moment, you'll feel weightlessness. It's like if you were in a bottle being thrown from one hand to the next. If you're inside that bottle, you feel weightless for the whole time that you're not being sort of controlled by an outside force. And so that instant that rocket comes off, you can take your seatbelt off. And you can start floating around the cabin and looking out the window. And then after a few minutes, it's not going to be a super long journey, but after a few minutes, we'll ask you to get back in your seat. And you'll put your seatbelts back on, it's important. And the vehicle will execute something called a feathering maneuver where the wings fold up. I don't know if any of you have ever played badminton. Have you ever played badminton? You know how the shuttlecock always points down? So it's the same principle with Spaceship Two. Basically, once the vehicle's wings bend upwards, as you see in this picture, it has a stable re-entry configuration. And so it can basically only go straight down with the bottom side down. And that's important because re-entry is obviously one of the riskier parts of space flight. At about 70,000 feet, the wings will defeather, that is to say they'll go back to their straight configuration. And then you'll just start circling downwards, and you'll land like the glider on the same runway that you took off from when you departed. And that whole journey will last about 2 hours. What will you see? So this is a real picture that was taken with Spaceship One. You'll see the curvature of the Earth, and you'll see the black sky of space. You'll feel the elation of weightlessness, which is, has anybody gone in a parabolic flight before or anything like that? I have to say, I recommend it to you all. It's a wonderful experience. It's something like you've never felt before. It's a fundamentally new thing, and it's a wonderful experience. So you'll be able to get out of your seats and have that experience. And then you'll be able to look out into the black sky of space, which actually excites me almost more than anything else, because we'll be able to see the Milky Way, and it should be a wonderful experience. So as I say, we've had tremendous success with folks from all over the world signing up to fly with us. We've got folks from over 50 countries, including many Mexican citizens. And they're wonderful people. They are people who are successful, but they're also a little bit crazy. And that's good because, you know, they have that special spark that says, I want to be an early adopter. I want to go to space right at the start. I want to be one of the first 1,000 people to go into space. And they're just wonderful. wonderful people. So in the development program, we're actually pretty far along. We have unveiled these spaceships now, and they've flown quite a lot. I think we've got a picture here. So we've flown the carrier aircraft now almost 100 times. We've flown the spaceship on free flights nearly 25 times. And so the next big milestone, which is coming up very soon actually, is firing the rocket engine for the first time. So what we've done so far is to fire the rocket engine on the ground. And what we have is a hybrid rocket motor system. I don't know how many rocketry experts we have out there, but it basically combines a solid rocket element of fuel with an oxidizer that's essentially a liquid. And so we've been firing that on the ground, but the next big milestone will be to put that system into the spaceship and to fire the motor in free flight. And that will be coming up very soon, over the next few months. This is just a picture of one of our recent test firings that we had. And it's very exciting when this thing goes off. You know, it's 60,000 pounds of thrust when it starts. And it's incredibly loud. And so when, when we do the tests, we're sort of, a good half-mile away. And, I think to myself, because I will fly on this vehicle, what's it going to be like when we're 5 feet away in front of it? I think it's going to be very exciting. So that's the rocket motor. Another interesting thing is that we're now hiring pilots, right? So, a lot of the space vehicles out there today, they're sort of capsules that you don't actually fly so much as ride inside of. But our vehicle is actually flown to space. It's manually controlled, and we have 2 pilots in the front of the vehicle, and they fly that thing up to space. And so we need some of the best pilots in the world to fly our people safely into space. And so recently we kicked off a hiring process where we said, if you're a test pilot and you've got all these different experiences, you can apply. And we had this tremendous interest from folks around the world in the test pilot community. 500 of the world's best pilots applied to be our pilots, and we've started hiring some of those folks. And they've got call signs, and they're very brave folks. Our chief pilot here is Dave Mackay. He flew Harrier jets for the Royal Air Force until he became a pilot or a captain for Virgin Galactic, and now he's our chief pilot, and he's just an incredible pilot. I want to talk a little bit as well about where we're going to fly, because that's a really interesting thing that potentially I think could involve Mexico at some point. So right now we are going to be flying from the state of New Mexico in the United States as our first venue, and what's very interesting is that all over the country and all over the world, in fact, spaceports, sort of the analog of airports, but for space operations, are appearing all over the world. And people, I think, have the vision to see that this is going to be something that'll come down the road, and it'll probably start off with suborbital vehicles that just do flights up and down. But over time, I think what we'll see is space flights between those spaceports. So, going between wherever, the United States and Japan in an hour or whatever, and you'll start seeing that high-speed point-to-point travel, which I think will be truly revolutionary for our world. So let me show you some pictures of our spaceport in New Mexico. So this is Spaceport America in southern New Mexico. I was there yesterday, and I think it sort of looks like a spaceship itself. I'll take you on a short tour of it. So the architect designed it so it's sort of sunk into the earth on the way down. And then when you come around the side, you see that it's got this beautiful glass expanse of people. Now, for those of you who don't know, whenever you do a big event with Richard Branson, you need to have something that he can either climb off of, or jump from, or do something special, because it can't just be a boring event. So last year, we dedicated the spaceport, and so we had to do something special. So we hired a dance troupe that was dancing on the side of the spaceport, and these are some of the dancers. And then, of course, Richard jumped off the side and dedicated the thing. But this is actually has a connection to Tijuana, because the day before, or actually the morning of this event, Richard was off the coast of Mexico, and he was trying to fly he was doing something related to nature and marine animals or fishes or sharks or something. And I don't want to get into all the details of the story, but he flew basically from that event to here, and some of the people who helped organize this conference were critical in sort of helping him to get there. And so that's a nice connection between here and there. So you can see this is a real picture. We've put the vehicle inside the spaceport, and that's where we'll be operating from. So we'll be taking people at the start, probably once a week, but maybe down the road, maybe once a day, into space from the spaceport. And we'll be able to fit 2 of our vehicle sets inside this hangar. And it's going to be just an incredible place. But it'll just be the first place. I think that's the main point. That over time there will be a series of other places that we'll be able to fly from and to show just all kinds of things that just to expand space technology. And that's an aerial view of the spaceport. The state of New Mexico built a very long runway, about 10,000 feet, just for this purpose, and it's a great facility. So I want to talk a little bit about the future of space commercialization now. So it turns out that you can't go anywhere and just buy a spaceship. So what we had to do was we had to set up a manufacturing operation to build spaceships. And this is something that potentially would also have a connection to the firms in this area. Potentially someday we could be buying parts or could be buying other things, integrated avionics systems from some of the great aerospace firms in your area. So we've set up something called the Spaceship Company, which is a company that's just dedicated to building spaceships. And it's a great facility, and that's the hangar there, and they're hard at work now building the next generation of spaceships, because we don't just want to have one vehicle. We want to have a whole system, a whole series, a fleet of vehicles that we'll be able to put all over the United States and then eventually put all over the world, sort of like the early days of aviation, where people could fly from all over the world, and where we could move these vehicles from all over the planet. And this was so we've been hiring a ton of folks up in Mojave, California, and we're hiring all kinds of folks, because it turns out we need all kinds of people to hire or to build these vehicles. We have a lot of folks who are space engineers, but we also have a lot of folks who are technicians and folks who know how to build carbon fiber composite materials. And what's interesting about our vehicle is that it is 100% carbon fiber. So it's the biggest vehicle system that is all carbon fiber. So the new Boeing 787 is about 50% carbon fiber materials. Our vehicles are 100% carbon fiber, and they've got things like the longest all composite wing spar in the world. It's about 135-foot carbon wing wing spar. And we've also, another interesting thing about the company is that we've also received a fair amount of investment from outside the United States. So we recently, a few years ago, closed an investment with an investment company in Abu Dhabi called ABAR, which is a firm from from that part of the world, and they put in about $380 million, which is, you know, doing these space projects is expensive, and it's very important to have proper capitalization behind these vehicles. What we're also starting to do now is to think through how we would do science on board these vehicles. And I think that's a very important thing, because they're not just going to be for space tourism. We're also going to be doing some really exciting science on board. Right now, one of the challenges of doing space research is that it's hard to get a ride. It's hard to fly into space frequently, because there are just not that many flights going up into space. But I think once we start operating once a week and eventually multiple times a week, what we'll be able to do is, you know, if you've got an experiment, you'll be able to just sort of send that to us, and then, you know, within a few days or a few weeks, we'll be able to put that experiment on board our vehicle, and you'll be able to get it into microgravity, into the space environment. You'll be able to do readings and observations at a much more rapid clip. And I think it will revolutionize space science. Because I think one of the challenges to space science is that it has been so hard to get experiments into space. So I think suborbital vehicles will be able to really improve that over the course of time. Now what I want to do is talk to you about a different thing that we're doing, but which is also very important, and it relates to a launch vehicle that goes into orbit. So I'm sure all of you are familiar with the distinction between suborbital flight and orbital flight. Basically, suborbital flight is when you just go straight up and down and you don't keep going around the planet. But when you go into orbit, you go so fast that you stay in orbit, and that's how you get satellites up. They essentially keep falling around the planet. And so one of the things that we decided very early on was that eventually it would make sense for us to have an orbital launch vehicle. And that's what we've designed. That's what Richard's holding in his hand here, the picture. Oops. It's designed to take small satellites into space, sort of 500 pounds into space. So what I'd love to do now is to show you another short video that talks about this new area, which we think of as very exciting because it will allow all kinds of organizations, you know, potentially universities, or small companies, even communities, towns, cities, to actually send their own satellite into space. So we'll bring down the cost of space access by orders of magnitude with this vehicle system. So if we could, maybe we'll show that video now.
As I travel around the world, I see increasing and often tragic evidence of how the depletion of our world's natural resources is affecting so many people in our rapidly expanding global population. But this downward spiral does not have to be a one-way inevitability. At Virgin, we're determined to do things differently, to lead by example, and show that business can be an amazing force for positive change. Better access to space is not a silver bullet, but it is one vital component of a better future. Over the last few decades, advances in technology have revolutionized the way we live, work, and play. And this also means that satellites can now be much smaller, much smarter, and much more powerful. But one big obstacle remains: the old and inefficient method used to get satellites into orbit. But all that's about to change. Say hello to Launcher One, a revolutionary launch vehicle at a revolutionary price from Virgin Galactic. With a launch cost aimed to be the lowest in the market, Launcher One is an air launcher from Virgin Galactic's uniquely efficient white-knight carrier aircraft. Launcher One will build upon the design experience of the existing Spaceship 2 manned space vehicle and leverage the unique manufacturing and flight testing facilities of Virgin Galactic's sister company, TSC.
Right, Steve, I've got brakes. You can pull the chop. Bobby, tower set 2 on holding short at 30. Request.
all in place to transform the business of satellite launch.
4, 3, 2, 1, release. Go.
Paired with purpose-built small satellites, Launcher One will enable scientists to tackle global environmental challenges with unprecedented speed and precision. New space businesses will be able to get into operation quickly and cheaply. Nations, states, cities, and even universities and schools will be able to launch dedicated satellites that will answer their diverse needs. Opening up space to everyone will allow us to see, experience, and benefit from it in many different ways. At Virgin Galactic, we've taken the initiative, and we're making it happen. Because space is Virgin territory.
Right, so that's our Launcher One, which we're very excited about, and we'll be able to, I think, fly that within the next couple of years. Maybe we'll do our first flight in 2015 or so. So I just have a couple of last thoughts to share with you. And I think it's directed in particular at the young people in the audience. So right now, basically all the people in humanity, all the human beings, live either on Earth or actually there are, I think, about 5 people in the International Space Station. That won't always be the case. So in the future of humanity, we'll have people on many different planets, probably around different stars someday. But you happen to live at the moment, you happen to have been born at the time that humanity first starts exploring the universe. That's such an amazing thing. I think you're so lucky, we're all so lucky to be born at that moment in time when humanity essentially starts becoming a species that expands off of its home planet. I mean, what luck. You know, humanity has been around for 200,000 years, and you happen to have been born at the moment when we start going off and we start exploring space. And I think, you know, of course, the moon landings were very exciting as sort of a place marker for the future. This is what we can do as a species. But I think that the suborbital vehicles that we're designing and that other people are designing will be very important because they'll bring down the cost of getting into space dramatically. So right now, the only way that you can get to space is to buy a ticket with the Russians, and it costs about $50 million US, which is a lot of money. Our ticket price is $200,000, which is still a lot of money. But keep in mind, the first tickets across the Atlantic Ocean were about $80,000 in an adjusted inflation way. Basically, these things always start out pretty expensive, but they come down in price. And what you need to do is establish that cycle where you have a price and then you have competition in the market and the price comes down, safety increases. And these first vehicles, Spaceship 1, Spaceship 2, we'll build Spaceship 3 eventually, will be the start of that competition that drives the cost of space access down dramatically and eventually opens up the stars for you and me. And so I just think all the time about what an interesting moment this is for humanity, where, you know, for 200,000 years, we've been basically stuck on the planet of the Earth, on Earth. And now is the time when folks who are involved in the aerospace industry will be building the first vehicles that start that journey to take us outward. And it's just a tremendously exciting time. As I think you've seen with some of these things that I've talked about, small groups of people really can build amazing vehicles. And you know, there's also a whole range of unmanned space vehicles that are under construction. And all these things will come together to form, I think, sort of the next space age. Whereas, you know, maybe the first space age was all government built. The second space age, I think, will be driven largely by the commercial sector and by entrepreneurial teams who are trying new ideas, doing things that nobody thought possible, and really coming up with the new ideas, the innovations that enable us to eventually travel outward and explore the rest of the universe. So I want to thank you for your time today. I think we might have time for a couple of questions if people are interested, but thank you so much for the opportunity to speak. It's been a real pleasure. Thank you.
A las 12 en punto, at 12 o'clock, we're going to launch in Tijuana two satellites with the young people and the university. Va a haber un lanzamiento de satélites hecho por jóvenes estudiantes que han participado en el programa de Tijuana Innovadora. We're so grateful that you're here and you give a splendid, very speech. We have to give you this because it's invented, it's designed by my friend.